hello everyone. How are you all? I am Siddharth Marja, and today I am going to talk about cost function and gradient descent. Okay, so in this we shall see how the machine learning model measures error using cost function and how they minimize those errors using the gradient descent. So this is the core idea behind the model training. Okay, so we'll let me go to the notepad for the better understanding and in detailed explanation. So let me open it once. So in this lecture, so far we have known about the linear algebra, how they represent data, calculus, how to function change, and the probability and the statistics, like how we deal with the uncertainty. So now comes to the core question, like how do machine actually learn from the data? Okay, so the answer is like define a cost or function. Cost means lose, so it measures how wrong the model is. So use gradient descent to adjust the weight to minimize the cost. So the key message is like optimization is the brain of the machine learning. Okay, so optimization is the brain of machine learning. Okay, so let's understand with the cost function. So let's go for this, like cost. What is cost function? Okay, cost function. Just a second. Yeah. So cost function is that measures the difference between the predicted output and the actual output. So function that measures the difference between predicted output and actual output is your cost function. So the goal is to minimize this cost. So our always goal is like to minimize the cost. Okay. So the common cost function are like mean squared error, which is your MSC, like common cost function. So the first one is your mean square, mean squared error, which is MSC. So what it is, like in regression, J of theta is equal to 1 by n into summation of I is equal to 1 to n y of I minus y cap of I ka square. So this is your mean squared error, or you can say the MSC. So for example, predicting house price. So for this we are using this. Okay. So the next one is MAE. Second one is your MAE. MAE means nothing but your mean absolute error. Mean absolute error. So what it is in the regression, J of theta will be 1 by n into summation of I is equal to 1 to n mod of y of I minus y cap of I. Okay. So this is your mean absolute error formula. And the next one, which is your cross entropy loss, or your you can say log loss. So log loss classification. So what is this basically? The j theta will be your 1 by n summation of I is equal to 1 to n y of I log of yi cap plus 1 minus yi into log of 1 minus yi cap. Okay, so the last one, which is your hinge loss. So in the SVM we are using. So in this the j theta you can write it like maximum of 0 comma 1 minus y into y cap. Okay, so this is about the hinge loss. So next we will understand like why different loss functions. Okay, so why different loss function. So the answer is like the first thing is regression. In this there is two, MSC and ME, and the second one is like classification. The classification there is cross entropy, and your hinge loss. And the last one, so this is two, and choosing the right thing, choosing the right loss function is equal to choosing how the model, should see error. Okay, so this is about like why different loss functions are there. So moving further, which is your gradient descent. Okay, so just do recap whatever we have did like cost function or your error management. So measurement. So the first two things which we have learned about the loss function, it is nothing but the error for one training example. And the next one is your cost function. Cost function is the average error across the data set. And the common cost function are like mean square error, like a regression problem, and the cross entropy loss in the classification problem. And lower cost is better the model performance. Okay. So the next one is gradient descent. So the idea is like to minimize the cost by moving the direction to steepest distance. So in this we are like updating the rules. Okay. So the thing is like gradient descent is an optimized method. So we calculate the gradient of the cost function with respect to the parameter. So the gradient tell us the direction of the steepest increase. So we subtract it to go the downhill. So the learning rate control how big step we take. So choosing the right learn rate is like critical. So too small Mac training very slow and too large cause the like instability. Okay. So let me go to the slide for in detail explanation. So as we have discussed, like the idea is the let's understand with an example. So imagine the cost function is a 3D surface like weight on axis, cost on height. Okay, so we want to reach the lowest value. Okay, so the gradient is your direction of steepest increases, and a gradient descent is the move in opposite direction. So the formula is weight formula is for the weight is like W is equal to uh, W is equal to W minus alpha of dou J by dou W. Okay, so alpha is your learning rate and dou J by dou W is equal to your gradient of cost with respect to weight. Okay, so it is repeated updates gradually minimize the cost. Okay, so next understand the types of gradient descent. So the first one is like batch gradient descent. So the first one is like batch gradient descent. So in this we are uses whole data set, whole data sets for each update, and it is stable uh, but slow for large data set. And the next point about this is, yeah, so I think this that much is enough. So this is all about the batch gradient dataset or a batch gradient descent. So the next one is like stochastic gradient descent, like SGD. So in this, uses or update using one random sample at a time, and it is fast but noisy. So that's why the third one came, which is mini batch gradient descent. Okay. So in this, there are 2 points which I want to mention, like compromise, compromise, like uses small random batches, and it is widely uses widely used in deep learning. So let's take an example of the linear regression and we'll understand it. So suppose y is equal to wx plus b is given. Okay. So uh, j of w comma b is equal to what will 1 by n summation of y of I minus w of xi plus b ka whole square. Okay, so when we take it the derivative like dou of j by dou of w, then what it will become 2 by n, correct, into summation of xi into y of I minus w xi plus b. I think I am clear. Okay, so the updated rules will be w into w minus alpha dou of j upon dou of w, or you can say the b is equal to b minus alpha dou of j upon dou of b. So I hope I am clear. So this is exactly how the linear regression learn. Okay, so we will move further. to the linear rate, learning rate, and convergence. Okay, so if there is too small, very slow learning, and too large, then overshooting or may never uh, converge. Okay, so if learning rate, learning rate and convergence. So if too small, too small, very too small alpha, or you can say learning rate, so very slow learning, and if there is too large alpha, then what it will be? Overshooting or may never converge. So the good practice is like to a small with to start with the small e.g. 0.01 adjust experimentally. So the graph scenario is like a small alpha is slow smooth descent and large alpha is zigzag or divergence. So in the practice, like use adaptive method like Adam and RMS problems. Okay, so the next is like your challenges and your variants. So the first one is like the local minima. So in this algorithm might get stuck in villages and in the saddle point, the flat regression or the flat region like gradient is equal to zero and slow learning. Okay, and the gradient vanishing. So in this, especially in the deep network, so the solution is like momentum and Adam optimizer and learning rate scheduling. So the next thing which we are going to see like ML application. So in ML application we can see like linear regression used for uses MSC and gradient descent. And the second one is like logistic regression use the cross entropy plus your GD. And the next one is your neural networks which is used for the back propagation and just the gradient descent or your chain rule. So the next one is SVM, which is hinge loss or your GD. Okay. So just summarize like what we have did till now. So we have understand like cost function, which measures how wrong a model is, and the gradient descent is the optimizer that improve the model weights. And we have also seen the variant like SGD and mini batch and Adam mix and learning practicals. Okay, so the ML at its core is equal to like define a loss plus minimize the gradients. So the next is like key takeaway from this entire session is like every modern machine learning algorithm it optimization at heart. Okay, so I hope this entire video helps you to understand the basics of cost function and the gradient descent, which is the heart of the learning. So till now, I am winding off this video. So in the next lecture, we will come with the new concept in the machine learning. So tab tak ke liye keep learning and keep exploring. See you in the next video. Bye bye. Thank you for attending this lecture, by the way. Bye bye.